So this is a great week for getting out under the stars. It's a moonless week. We're going to have our new moon on Friday. So we've got all this week with dark sky for evening observing and a great time to tackle some of these objects. The whole purpose of doing this is to give people fresh things to see beyond the Messier objects. So these are the finest NGC targets. I'm going to mention 5 of them that are residuals left over from the autumn group, because it's not until really later in the night that the winter targets get nice and high. But a lot of the autumn ones are still around thanks to the early sunsets. So the first one I've got to mention is finest NGC number 15, and it's called the Skull Nebula or the Soap Bubble Nebula. It's in Cetus, the whale. You can see here, there's Cetus's head, his body, and his tail. There's Jupiter, just to give you the context of where you're hunting for. This is the sky around 8 p.m. The sky is actually dark after 6:30. In Toronto, at least, the astronomical twilight is over at about 6:30. So the sky is still fully dark around 6:30 to 7 p.m., depending on where you are in the country. And I recommend tackling this one in early evening. So while it's still close to the culminating point, due south. Otherwise, if you wait a little bit longer, it's going to sink down into the west. And the Skull Nebula is a planetary nebula. It was discovered by William Herschel. Whoops, where are my planetary nebulas? I turned them off before. Here we go. Discovered by William Herschel on November 27, 1785. It's this category 5, number 25. You need a relatively large telescope and or very dark skies. You can see it's not a very bright object. You can see these stars, these field stars, with a smaller telescope, but you'll have trouble seeing the nebula itself. It's also called Caldwell 56, which is named for Sir Patrick Moore's list of his own top 110 objects in the sky that aren't Messier's. It's pretty low in the southern, it's pretty low in the sky for Canadians. So that's why you do want to sort of tackle it while it's close to culminating if you can. You can look for a triangle. So if you can see the stars of Cetus, and you can find the trio of Deneb, which is Eta, Ceti, Diphtha, which is Beta, and Deneb Kaitos, which is Iota. If you can find that triangle, then point your finder scope kind of central to that triangle, and that's where the Skull Nebula is. You can also, when I found it in my star hopping, I used this line of Alnatham. These are the kind of phi 1, phi 2, phi 3, phi 4 Ceti stars. So if you can see those even in your binoculars, then you'll know where to point your telescope, sort of just below that. And by the way, the distance below those would be about 1 degree. So it's really in that neighborhood. If you're using a nice wide field of view, you'll even be able to fit either of these stars in the eyepiece with the Skull Nebula, but you want to nudge them out of the way when you're really looking at the dimmer object. So this object is optimal at around 65 power. When you're looking at it, I think I can put up the eyepiece view here. Let's see, I've got, whoops, let me go back. I hadn't selected the skull yet. Here we go. So that's kind of a telescope view at 65 power. This is through a 6-inch Newtonian reflector using a 14 millimeter Plossl eyepiece. What you want to note for when you're looking at it is you want to look for the shape and structure of the nebulosity. Can you see the skull effect? Sort of these dark voids that give the mouth and the eye appearance. Can you see the central star, the 12th magnitude central star? Look for the field stars that are superimposed in and around the nebula, and check that out. And if you have an oxygen 3 filter or a UHC filter, highly recommended to enhance the nebula itself. This one's about 1,600 light years away from us. All right, next we've got what Samantha has behind her head. It's NGC 936.
I think I have to talk for them to be able to see it here.
There we go.
There you can
this
see
one's
me.
at the other end of Cetus. There you go. This one's actually near the star Mira. We covered Mira during our variable star sessions. So it's kind of between Mira and Messier 77 in Cetus. Its nickname is Darth Vader Starfighter. It's a small but condensed barred spiral galaxy. So there you go. You can see it in Samantha's background or here. So there's the center core of the galaxy, the bar stretching across it, and then the ring-like disk or halo around the object. Really, really cool. It was discovered by William Herschel in January of 1785. It's his object 4-23, so 23rd object in his class 4. I think he thought it was a planetary nebula, which is why he put it in that category. The neat thing is that the core is actually condensed and bright enough for smaller telescopes. You'll need a bigger scope to see more of the structure, but you can certainly find it and see part of it in a smaller telescope. I have it down as midway between the star Mira, the star Delta Ceti. So let me just bring up my pointers here. So I think this is Delta Ceti and the star 66 Ceti. So if you see 66 Ceti and Delta Ceti, it's kind of almost midway between those two stars. So you should, if you point your finder in that general area, you'll pick it up. What I did is I actually star hopped from Delta, which is this star here. I found 75 Ceti, which is a relatively bright star. And then I just moved the telescope west by 1 degree to pick it up. You'll want to use averted vision. You'll want to look for its orientation, how it's angled in the sky, its shape. Look for any field stars around it. You can see here there's a sort of a triangle shape of star. This is actually another little galaxy in the background. Yeah, and there are some other galaxies in the neighborhood. There's a 941 here and 955 here as well that you could check out for. I used about 100x. So this is 65x. You probably want to use about 100 power on it. Remember, don't filter galaxies. So that's that one. Up next, we've got NGC 869, NGC 884, better known as the double cluster. So, here's an example where something that's binoculars target, naked eye target from a dark sky is in the finest NGC. So not all of the finest NGCs are out of reach of beginners. So the double cluster is up here in the space between Cassiopeia's W and Perseus's bright star Merfac. Really an autumn showpiece discovered by William Herschel in November 1st, 1788. So they're number 33 and 34 on his class 6 targets. Each of the clusters are about the size of the full moon, and the centers are separated by about the diameter of the moon. So they're really a fantastic target to look at in binoculars. As I said, you can probably see it with your unaided eyes if you get away from the city lights on a moonless night. You can also, if you're not sure about yourself, again, you can find Merfac and Navi and kind of aim right between the two stars, and that's where you'll pick it up. Now, when you're looking at it, if you want to zoom in with a telescope, don't over magnify, say 35 power, that kind of thing. And you want to start sort of noting the distinctive individual characteristics of the two clusters. So the lower one here, 884, is more sort of sparse, less concentrated. The northerly one, 869, is more dense. You're also going to be looking at the various stars that populate the cluster and look for things that are a little bit different. So for example, you can see that not every star here in the view is a blue-white star. We've got some different colors coming in. So that's the sort of thing you want to be noting in your log looking at these objects. They're about 7,100 light years away in the Perseus arm of the galaxy. Okay, I got two more. One is the Perseus lenticular galaxy. So if I swing around here and look at Merfac, by the way, Merfac is fantastic in binoculars because it's got a neat clump of stars around it. But if you look down the arm of Perseus to the west, you've got the variable star Algol. And if you look just to the direction of Triangulum, you've got the Perseus lenticular galaxy. Perseus lenticular galaxy is a medium-sized kind of barred lenticular galaxy. You don't get a lot of the structure on this one because it's lenticular galaxies are not spirals. They're more of just a blob, a shape. Discovered by William Herschel on October 18th of 1786. It's number 156 on his class 1. It's center is dense enough to be visible in, say, a 4-inch telescope, and definitely a larger telescope in darker skies will give you more and more of the size of it. It's about midway between Algol, so if you find Algol, and Mizan, which is one of the corners of the triangulum, then it's about midway and a little bit higher than the center point between those two stars. So that kind of gives you a way of getting close to it. Let's see, I've got several medium bright stars in the neighborhood to pay attention to. I think use around 60 power, maybe even a little bit higher, but don't search with a high power. You want to search with a lower power. Now, some people talk about it being a little bit peculiar. So if I zoom in here, you can see that there's kind of a little spur off one end that won't be visible that well in amateur telescopes, but it's considered an ARP galaxy, a peculiar galaxy from that catalog. It's about 34 million light years away. And while you're in the neighborhood, you can look for the Silver Needle galaxy, which is, or Silver Surfer, Silver Needle, which is just in the neighborhood. We've covered that one before. This is a really nice object in backyard telescopes, amateur telescopes. Okay, last up, still in Perseus, is the Fossil Footprint Nebula. Where's my Fossil Footprint Nebula? Just find it here. So again, if you start with Murphak, when you're looking at Perseus, if you notice, and again, Perseus rotates its angle through the night because it's a circumpolar constellation. But if you can find Murphak and Algol, you want to kind of make a right angle, east of those. And you can actually follow Perseus's arm. There's a number of sort of medium bright stars that curl down and make kind of an arm here. And the Fossil Footprint Nebula is near this Lambda Persei star. This is a great object. Stephen O'Meara, the famous popular astronomy author, he sort of describes it as an object that's visually small but photographically big, because the center of it is bright and visible in medium and small telescopes. But the rest of it, you need either to take an image or have a really dark sky and a really big aperture to see more of it. He kind of imagines there being lobes of gas that sort of stretch out and make it look like a sort of a three-toed dinosaur foot, that sort of thing. That's where he gives that nickname from. The way I find it, the way I recommend finding it, is that you can look for Lambda, if you can find Lambda Persei, or you could point your scope midway between Epsilon Persei, or Epsilon Auriga. Let's see if I can find that one. So let's see, Epsilon, I think should be Almaz. So if you make a line from one of those three kid stars near Capella and draw an imaginary line up to the head of Perseus, Miriam, then the fossil footprint is right on that midline between them. So that's another way you could find it. Okay, in a telescope, that gives you a sense of it at 60 power. So you probably want to use less than that. So use your 25mm eyepiece to be able to fit nicely the whole object in the view. When you're looking, you can zoom in to look at the little cluster of stars that are born in the center of it. You can look for the shape of the nebula, the structure, see if you can see any of the bright little sort of fingernails of brightness, and then the dark voids that are scattered here and there. Depending on your conditions, you might see more or less of that. You definitely want to use averted vision. Definitely want to use your UHC high contrast filters or your oxygen 3 filters to help. This one's about 12,000 light years away, and that's it. Now, I will mention just before I wrap up here that there are 4 more autumn finest NGCs in Cepheus, but because Cepheus is sort of, let me just bring these up, because Cepheus is kind of dropping to the west side of Polaris during evening, it's not the best time to chase them down. So we'll save those and we'll cover them in the summer, because once we get to, say, July, they'll be visible kind of late night. So we'll do them then. And that's it.
Any questions? We have thank you for all the tips and useful information, Chris, in the chat. And I don't know how you do it every single time, right at 5 o'clock. He told me he didn't plan this, but he knows. Okay.
It's not my first time. It's more like my
No,
65th
no.
time. So I'm getting used to it.
Yeah, we're like 60 or something more. Okay, so we are still in the process of making the schedule for our topics in the upcoming weeks. So if you're interested in like taking a sneak peek, it will post on our website. It's available. But we're back to our regular schedule. So I think February 1st is the next time we will be back. We'll become no, January 31st, right? January 31st
2 weeks.
as our
Yeah.
next episode, and stay tuned. So
Terrific.
you
Yeah.
all.
So for those asking for the detail, to clarify the details on the positioning, don't worry, Samantha includes all these notes in her online post. So she'll go to RASCA and you'll find all my notes that I've mentioned there.
Yeah, it'll be up by the end of the week, hopefully. Yeah. So okay.
Perfect. Clear skies, everybody. Good luck
Clear
with the moonless nights this week, and hope you get clear skies for the comets. So